Hello everyone, in this video we will analyze the existing quantum PLC hot standby project. First we will review the project configurations, variables and address formats used in the system. Then we will go through the user defined function blocks, that is DFB, used in the hot standby systems, and understand the PLC diagnostics addresses used in the program. After that, we will check the hot standby system logic in the program and verify the switching and control logics are implemented. We will also review the project settings and advanced project options related to the system. Finally, we will see how to add function blocks using the library browser and understand different blocks types such as FFB and other functions. We will also open the Unity Pro or Control Expert software and learn how to open the existing project. This video is useful for beginners and engineers who want to understand quantum PLC or standby project structure, diagnostics and function block usage. Open the Unity Pro or EcoStruxure Control Expert, then go to the file and open a project, and once you click the open, it will open the existing project. In my case, I am going to select my existing project called Quantum PLC. If you see here, you can find this type is STU file extension, and if you need to open the open option, you can select open the project in read mode only, and in the right side you can find the existing project version. If you need to update the project version, you can select here in the right side, and you can find here from version 10 up to version 8. So you can select any of the version. In my case, if I need to select same version, I can use the keep same version. If you see downside, you can see the project informations here, name, type, modification dates and everything. And once you select the project, click open. It will open the complete project in structure view. In the left side, you can find in the browser project browser as a structure view, and here you can find configuration, the function derived function types and variables and communication programs, etc. In our case, just I am opening the existing project, so you need to be select and see the configuration how we made the existing project. So in the left side, I am just going to select this local bus and EIO bus. In local bus, if you see the local bus, you have here quantum PLC, CPU, power supply, CRP and NOE module, and this is hot standby redundant configuration. If you see in the EIO bus, you can find two bus drops, like a 2 drop EIO bus drop, one for EIO quantum drop 1 and another one EIO quantum drop 2. So similarly, if you have more IOs or more, if you need to add more remote drops, you can add here. And if you see in the configuration, in the local bus, I am going to select this configuration. For that, double click the local bus. It will open the local bus configuration, and if it will be open in the hardware catalog in the left side. You can close that one and check the option here. See here, if you need to change the power supply, right click and delete the module first and change your module. And if you select the power supply option, you can find here how much power it occupied in current stage or it's consumed in the current stage. If you click the CPU, it will the current CPU model is CPU 674, and if you need to see the power consumption, it is 2.5 ampere. And you have here, see this CPU 67160. No? For the CPU, if you double click that one, it will open the complete overview of the CPU, and you can see the configuration exactly the overview, that is specification of the CPU. Here you can find all the specification here. You see the model and the CPU capacities, how much ports you have, communication ports, processor types, speed and everything. Even the types like battery types and everything. If you click the summary, you can find the summary of the CPU And the main thing is in the configuration here. See here you have cold start only. If you need to click the cold start only, it will open only cold start. And if you see the operation mode in the automatic startup in run, or you can select the initiate percentage MW memory word futures. And also if you see the memory card, you can find the existing memory card which you added in our project, and it is showing the capacity of the memory card. It is 4 MB. And if you see further down in the communication, you can see the maximum input data of the communication speed. And also in the right side, you can find the state RAM, that is how much RAM we utilized. And if you double click that one, state RAM viewer, you can find all the status here. See here currently it's not showing any status. So if you see in the downside, you have percentage memory, like percentage M memory, percentage I, percentage IW, like that. If you select the module, variable and language, you can find which one is occupied and which one is free slots. So you can see, if you need to select only modules, you can select particular one and you can check. See the module, it is occupied with 0 and up to 199, and this is for modules. And if you need to check that how it is occupied, see this all DI and these physical inputs, all these are connected with the modules. For that, if you need to check exactly, see if you click the variables, elementary variables, you can find here the addresses. In this address, in the address mode, you can find all this address. This will be occupied in the first 0 to 200. And if you select these other variables, it is selected for like after 200 to up to 1000, like this. So you can find how much RAM you utilized or how much variables you utilized in the project. If you go further for Modbus port, see you can select here, you have 3 Modbus port, and the first port, second and third. And the first, if you see in the hardware configuration, it will mention there MRP, and the CPU first one is USB. And if you see the downside, you can find the other 2 ports. For that, if you check in the configuration, you can change the baud rate, data type, stop bits, parity, and everything. And for the first one, you can change either Modbus, RS232 or 485. But the second and third port, you cannot able to change because it is only RS232 port only for port 2 and port 3. For the port 1, you can change either RS232 or Modbus RS485. And the next one, if you click the animation, if it is collected with the live, you can find all the values there. But in our case, this is very important to select or standby. See here, run mode, I selected both Control A and Control B in online mode. And if you see in the standby logic mismatch, it should be offline. And if you need to make invalidate keypad, you can select here as well. And also if you go for straight RAM, it is selected start from percentage MW1. And if you go further for IO objects in the CPU, see if you select any one, like example percentage I am selecting now, you cannot find anything because the IOs are all configured with the remote IOs, not in the same CPU. So if I select anything for percentage IW or any of the in IO objects, you cannot find any values. But if I am selecting the CPU objects, example I am selecting percentage S, SW, percentage M, MW, like that. So it will generate all the objects in our project, because this will be stored everything in the CPU. See, you can find all the percentage SW, percentage S1, S2, S3, like that. So, and also you can find, this is for system address, and if you system bits, S1 percentage S means system bits, SW means system word, and M means percentage memory and memory word, and also you have percentage MD and MF. This is for double integer and float. And you can find all the like a float means real value. See, here you can find all the objects in that side. So this is the overview of the CPU. Now I am going to click, just we selected now the CPU. No? For that I am going to see, now you have only one memory card, correct? Now I see this one added here. If I need to add one more memory card in the same project, so what I will do in this, if you see here, you can delete this module as well. And if you need to replace the memory card, you can change from this place, see here. And you can find all the part number of this particular CPU, and you can change these memory cards. And you can change either flash or SRAM, or see, this is the SRAM memory card, and this one is SRAM data storage memory card. And these three, flash, SRAM and SRAM data storage. If I need to add one more memory card, see here, if I right click and add new, and it is showing now here you can add only this SRAM data storage only, because ERAM we already added upside now. So it is showing in the downside to add. See, now I added this second memory card here itself. If I again double click that properties, you see here we added two memory card in this case. One is for like port 1 memory card, and another one is port B memory card. So there is you can add up to 2 memory card in one CPU, and this means you need to purchase 4 memory card, because this is one, you have another one more CPU, no? With this is because this is odd standby. So you need in one CPU 2 card and another one 2 card, that is 4. In our case, we are going to add only 2. One is in one CPU and another one is second standby, secondary PLC. If I double click the CRP, and if you see the CRP model CRP 31200, if I double click that CRP, it will take little bit time to open the properties at the first time. And also you need to be add one NOE. This is if you are going to select any one of the odd standby PLC. This will take you need to be consider one power supply, one CPU, one CRP and one NOE. See, now once I open the CRP, you can find here all the data of the CRP. The CRP means Ethernet IO head. And if you see in the this is the configuration in the device IO head module. And you see here all the device for this Ethernet configuration IO module, it's automatically configured internally inside the module itself. See, once I select that module, you can find the data variables directly. See, if you see the overview, you can find all the addressing like specifications, and in the IP configuration you can find here automatically, because we have here 2 CRA module. No? This 2 CRA module, it will be automatically configured in this CRP module, because it will communicate through the CRA modules will communicate through the CRP only, the configuration. So it's added automatically, and also you can add by manual as well. If you go for RSTP, this is for communication purpose, and you can keep the default. And if you go for SNP and NTP, you can keep everything default as well. And for service mode, you can add the service port as enable or disable. So in our case, we need to make a service port enable, and the service should be SS, and source port should be like if you need to make more like internal Ethernet 1, 2, you can add that to enable that port. But in our case, we can keep the default. And if I go for the device setup as well, and you can keep the same. And if I double click the NOE module, the NOE, it's basic web service module, and this should be useful to make the redundant communication in any of the quantum PLC. And even for M580 CPU as well, you need to be configure these setups, because here you need to be use one CRP and one NOE module. And this NOE module, see, you can find all the specification of this module here. And this is very useful to make the redundant communication between these primary and secondary IO drops. Like we can tell that primary and odd standby. If we need to make a odd standby, this is very important to understand that concept. Okay, this is very important to know that what is the function of each module, what is the use of CRP and NOE. And if I double click the EIO bus module, this is the EIO bus, and we already configured 2 racks in the EIO. Once we open the EIO bus, you can find here 2 racks which added in our project as per my specification. So you can see the bus, there is 2 bus, one for first rack and one for the second rack. And the CRA and CPU, see now CRA and CRP. CRP should be used in the main header, that is main PLC in the redundant configuration. And for the remote IOs, you have to use CRA. Okay, but in the CRP, see the CRA module, it should be configured. See, this is the IP address of CRA module. See, now once I double click the CRA, you can see the difference. See here, you cannot find, see this is the overview page and the specification, and you can find only RSTP, SNP and service port. Service port should be enabled, and this will be take automatically from the, once you configure the CRA, it will be take automatically the IP address, and it can locate. See, it is configured for the CRA address is same like 192.168.1.3. it is like it will take default. And if we click the IO address, you can find here the IO address starting from 1, that is %I 1 up to 32 for the first slot, and it will take default at initial stage. If you need to change the address, you can change from directly from the starting address in this place itself, but in our case we can use this default %I 1 to 32. Similarly, if you go for the second module, third, 4, 5, etc., it will be add automatically the IP address, like directly take the address of that one. See, this is for output module. Output module, it will take %M, then 1 to %M 1 to 32 for the first card. Similarly, if you go for the input, analog input, you can find the addressing. See here, %IW, so it will start from 200 to 216. So whenever you don't need to worry about the configuration, because it will, once you select the module, it will automatically add the address of that modules. So this same address you need to be configured in the elementary variables, that is you need to define, it will you can add the name of the each address. Like example, %I you need to be used for, see now I double click the elementary variables, I will show from here, so you can understand more about this. And if you need more about how to the basics, you can go with the previous tutorials. So we have the lot of tutorials available in earlier, so you can find that one for the basics, because this will be like little bit advanced. So I'm going with the directly, I'm showing the address how we can add, like how it is added here. See, just if you go upside, see here you can find all the addressing. See, this is the address of each one, and we can add the names. This name should be added, and the address at initial time you need to be add from the same like here. See this one, %M 1 to 32. Yeah, 1 to 32 you can find here. See here, this is the address for digital output. This is the address for digital one. It is for solenoid valve open or close command, that is NO SDY 017. This is the tag number of the solenoid valve. So similarly, you can see here all the commands, that is it is for digital output, it's already added in this side, and see in the addressing format. So this is for digital output. And similarly, if you go for other variables, see if I click the analog 16 input channel, it is %MW 200. For the 200, if I click, see here the %IW 200. So if I go further down, I can find the addressing here, %M, and if you go further down, you can find percentage here. This is %MW. But if you go further down for this addressing, I think it is upside. Before the %M, you have %IW. See, after I, if we see here, we already configured IW. This IW for analog input. See, percentage, first address should be percentage IW 200. That is for level indicator transmitter. Same you have for temperature, level 2, conductivity, pH, differential pressure, level for another section. So this all it is already configured in the project. So we given the tag name and description in the elementary variables. So each address it is already mapped and configured in our variables. Therefore, you can find all the addressing here. So this should be created from our side. Now it will not create it directly, because only it will show you the default address. You have to create here. See here like this. Double click in the name place and you can add any of the name. See, similarly now I am just showing one address for sample. See, now double click this place and I am going to enter called DI001 and it will show boolean. So you can change this one to E boolean. E boolean it is used for any of the physical inputs. Boolean it is for input like a system address, but E boolean should be for any of the physical address. If you need to connect physically, you have to consider for the digital inputs, you have to consider E bool. And I am going to provide one address called percentage I120. Once you entered, it will be directly mapped with the hardware directly. So this is the overview how you need to be configure the elementary variables in our projects. And similarly, you can set if in the value section, you can add your, see here we already added for timers. Similarly, if you need to make add some values at initial stage, whenever the CPU starts, you can add the value as well. See here we added some of the values. And if you go, this is for variables. If you double click the DDT, this one currently we don't have any derived differential functions. And if you go for function blocks, here it's already created. What are the in the logics? Once you create some, you see this is for scaling and this is for set resets. And if you go further, you have many counters and all the counters scaling or any of the functions blocks which you used in the projects. This will be automatically shown in the function blocks. And this differential, this is DEFB, that is the derived function block. The derived function blocks what you created already, it will show you in this place. In our project we use two DFV types. One is scaling 1 and scaling 2. See this one you can find in the left side, derived function block types. And you can similarly you can find the, see this is the digital inputs, outputs, input, output, public, private address. This will be shown in our derived function block types. Again I am telling you this all, it's already we explained in many times in our Unity Pro basic tutorials. So you can, if you refer that one, you can understand how to create this scaling blocks and everything. See this is all inputs you can find. If you double click this scale block which we created, and you can find here, see EU, max, min and analog input raw values, and also you can find the scale variables in the output. So this is one of the scaling function block. This is one of the standard scaling function block we created for any of the analog inputs. You have maximum value, min value, and you are going to subtract, multiply, and after that you are dividing the value because you are making a scaling from initial integer value to real functions. For that we make some functionalities for scaling. If you we already have some videos for scaling, how to make the scaling functions, you can understand from there. And if you go further, this is for derived function blocks. And this if you go further, you have elementary variable, derived variables, device DDT, IO derived variables, elementary, like this. And if you go further down, you can find here the function, that is program functions. That is here in this section you can add all the programs like what we added at a earlier stage. This see you are, this is one of the big application. See, you can find here all the programs here. And in this section, I'm just opening some samples. See here, we already make some scaling, some logics for the dosing pumps, and also we make some logics for HMI read and writes. And also if you see some control logics for uh, some of the units, those example dosings, calcium, magnesium, and also for the auto sequence of the pumps, everything. Now just I am showing you the PID control. See here we make some PID. Once I right click the PID and click the help, it will open the help menu directly. See here we can find the help of the each functions, and you can see this function example. FPV means what is the data type, real or integer or anything. And also if you go further, you can find the formula of the PID functions, and you can understand the complete function block details in this help file. This will be very useful for everyone. And you can make even see this, you have the set SP and process value and set points, and it will how the function block is going to work, everything it is explained in the help file. See here you can see how it is converting the values from the function. And also you can see the runtime error. If there is some error is coming there, what is that meaning? So everything it is showing in this one, and the description it is very clear to understand. And you have many sub another like leaks. You can click that one, it will go for the basics, advanced, and every help in each of the places. Example, if you select any of the block, example or and or even PIDs or any like a small to big functions, you can it's have the complete detail in the help file. So this will be very useful for the any one of the beginners of to understand each of the functions. So this is the overview of the program functions, but still we are going to see some of the important function here. See, this is very important for PLC diagnostics because this named from our side, and that PLC diagnostic is function block diagram, which we created this all the logics. See here you can find the PLC or standby status word read, and if I click that right click that one, it is opening in the help file. Just I click the right side, right click and help on type, and it is showing the complete function of that or standby status registers, how it is working, and what types of data you can take in this block. So it is showing everything. See here you have or standby configuration found, and this is you can find the status of PLC, whether it is offline, primary, or standby PLC. And also you can see the other functions PLC for both identical. See, both PLC program are identical or different program, because you have two PLC, one is primary and one is standby. So if it is not, if the PLC is different, you can find from this place itself. Similarly, if you go further down, and you can find this PLC is PLC A or PLC B, which you open the logic. Maybe if you open in there is two PLC. Primary you can tell that PLC A, and standby you can tell that PLC B. So you can know which PLC you open currently and what is the status of the PLC. It is the program is identical, or it is primary, online or offline, everything. And if you go further, you can find, before that, if you open this help, and if you need to search some of the addressing, example, if you go directly search, and if you enter there, it will show you. Otherwise you need to go in the index. It's just I'm going to enter example, the same addressing which you used in the primary mode or standby mode. For that, see, now we used percentage SW61.1 and 0. See, if I go here, and you can find here percentage SW, see, this is 60 to 69, it is for quantum. and 6265 for premium also you have that in the same place. See here. Now I'm going to select the quantum. If I select the quantum, here you can see that one percentage SW 60 to 69, it is used for odd standby quantum PLC system words. And if you see 61, you can find the address. This is for odd standby status register, and the function, and it is showing you percentage 61 and 62, it is used to operating board for either offline, primary and secondary mode, that is standby mode. So if we use percentage SW 61.1, if it is equal to 0 means it is if it is 1 means it is offline, if it is 0 means online. Same for primary, percentage SW 61.1 is equal to 1 means primary and standby. So we make the logic based on that. See here in AND logic we make already, if it should be 1 not 0, this means the primary mode. If you see second one, we mentioned for standby mode. From there SW 61.0 should be 1 for standby mode, and also you can find odd standby mode. And if you go further, we mentioned about the RIO drop, remote IO drop. And for this remote IO drop, we will take percentage SW 535 176 for RIO drop error, and percentage SW 61 it is for offline mode. Further, if you go for status of the PLC or A or B or primary, I am taking the signal because this one already it's configured in the first one as odd standby status. From there we already make the output. That output it's connected with our input in the status of PLC A or B mode. So if you need to make some logic to shown everything or seen everything in the SCADA or HMI, you can utilize this function block like this, all these blocks, because then you can read. See here, even I can read the analog output or input, digital inputs, any card, detail of the card. See, once I select the PLC details, see here E drop status. Once I take the status of that PLC, see here already we already mentioned this is for local PLC station rack module status bit. See here, and if you see here, you can take each channel as well, and each channel you can check the status. Maybe the channel is failed or 4 to 20 milliamp, below 4 milliamps, or up for above 20 milliamp, it can be shown directly from here. And also you can check the firmware version of each CPU, CRA, power supply module, everything there. And also for each analog input, digital inputs, analog output and digital output. For everything you can make the logic, like you can take the block and you can utilize with the system words, and this will be configured in the SCADA system. This will be very useful for any of the beginners or engineers who need to be shown every signals in the PLC. You can make from. You can use this type of system words. And now we go for the alarm. See here, I already configured for low alarm high for each example, the tank level low or tank high, and I am just configured this same address for HMI. Therefore, I used one more bit to take for HMI as well. And some of the bit we make for, see this example NO ZSO underscore 007. I am taking this one for HMI with time delay as well. So this all, it is useful for alarm. And for the scaling level, which we shown before, now the same here. See, if you see the scaling here, you can find how we configured the scale. Like example, we make already before the scaling. And if you need to verify that again, go to the previous videos. You have the analog scaling. You can understand how we make the scaling blocks. And already it is defined in the DFP derived function blocks. You can utilize directly from the derived function block, and you can directly take the tags from the variables. and you can find here all the scaled value, and I'm taking here the scale value, and it's already calculated for the analog scalings and we utilized in the project for and also it will be taken for alarm and set point for each analog or analog input and output addresses like tags. So this is the overview how we are going to make the analog scalings. Similarly, we have for level, pressure, temperature and flow. See, if I double click the flow, I can find here, see this is the flow scaling, and you can enter directly from HMI minimum and maximum level. You don't need to make connect like entered here directly. So you can make from the HMI as well. Once you enter the low level and high level in the HMI scaling range, it will be directly implemented to the block. So the address will take directly, and based on that the flow rate, the flow will be changed. See here already they mentioned the flow range for each place. What is the range? It is 5000, example 50,000 cubic meter per hour, and we already make for each place how it is changing. This is the scaling block. And similarly, if you go for PID control block, you can find here the control block which we used in the project. And this one, if you need, kindly comment in the comment section. I will explain the PID further for the any of the next videos. I will explain more detail for the PID blocks. And if you see here these PID blocks, it is taking the pump values and taken some flow rates, and also for the conductivity, flow and other details. And it is once it's enabled that all the conditions, the PID block will start enable to work. And you can see here there is process value, set points, manual, auto, parameter, and we have some TRI and yes. This is for some additional function for integrity and other values, and it will give the output of the block. So you have lot of functionalities. You need to, because this is one of the biggest project which we used in our one of the plant for the water utilities. So if you see here, you can find there is many blocks in this project. And if I double click this one, you can find here HMI write value. This one, it is taking the input of our value and it is writing to the HMI. So similarly, if you see all the outputs like this is HMI write. This means HMI will take the we are taking the input of physical address and we are going to write to the HMI, because this directly you can map each address. This you can use even in the function block diagram, because now this one which we shown is ladder logic. If you need to use function block, you can use move function block, and this one directly it will move one bit to bit to bit. And also you can utilize, if you need to utilize, you can utilize bit to word. This case you can use all 16 bits and take as one word. This is also possible. So in our case we use directly here bit to bit directly, like we can tell that move function. Therefore we in ladder logic we directly mapped with each IO, we mapped with the output of the HMI. And if you go further for physical output, and if I see here the physical outputs, here this is for the dosing screw start and stop pump logics, and we see we have lot of logics. See now we are checking the totalizer. In this totalizer we have for each 2 seconds we are going to divide the flow rate and by 10, and we are taking the output of the flow totalizer. Okay, this is the overview how we make the flow totalizer in this project. See now we checked how to make the configuration, variables, programs, and how to utilize in the logic, like how to use these variables in the logics. This is the overview for the project brief. Now we are going to make some advanced level. We are going to check how to make the project settings and also advanced options, and at the end we are going to see how to check how to use the functions and function block by using libraries. So now once I double click the project setting, we can see in the tools you can find the project settings. Now we are going to check the project setting and options. For that, go to the tools and click the project setting. Here you can find in the general management of build messages, you can find all the variables types, and also you can check like you can select the generating parameters and also errors allowed and warnings, everything in this place. And if you go further for build settings, here you can find the created data blocks line and also other parameters. And if you see for project auto savings on download, you can select default, it is having that STEA. You can save STU as well as XVM files as well. So in my case, just I'm adding STU. And if I go further down, I am going to make for PLC embedded data. Here you can see the data dictionary changes. Example, if you need to be add or change the data build changes on timeout seconds, you can change, and also upload information managements, optimization of data online change, everything you can find in this place. See, some of them it is you cannot able to modify, but most of them you can able to modify, and even you can add the upload information commands. See here animation tables you can add. During upload you can add animation table as well. So if you select that option for animation table, in this case our animation table also it will be uploaded, like downloaded in the program whenever you are uploading the informations. At the time you can upload the animation table as well. So you have a lot of options here. And if you go further for PLC diagnostics, you can find application diagnostics and also system diagnostics, and also rack viewer diagnostics, program view diagnostic, etc. And for PLC behavior, you can reset from stop to run in this place. And also similarly for time. And if you go further, these variables, here you can select the variables. See here the character sets, it should be standard. You can select allow for e-boolean and integers, and also you can select for allow the integer word and byte, and also for dynamic array, and other you can save restore data request as well. And if you go for the program, you have languages, common language, this is for common. And here you have a lot of functionalities you can make. Example, you can set the ST expression to ladder or function block enabled, and also you can select multiple assignment for ST and ladder logic, etc. For the function block, you can select for number of rows and columns, how many you need in each place. Similar for ladder logic, you can select the number of heights, lines, etc. And for ST, you can select allow jump the places like nano and multiple rows. And also you have LL984. This is for another type of function program language. We can see that one later on. See, now in the operator screens, you can select as well how many screens, see how many in the project you need, how many screens and everything. So this is overview of project settings. If we select the tools and options, in this place it would be open all the option in the management. See here the option management, you can find auto incremental of project versions, auto completion of project variables, display the error or messages, path See here you can find all the paths located for the project. See here the where exactly the project path, and also for the all the backups you can find these places in the path. And also if you go for data and languages, you can find spreadsheet behavior, and also for LL984 in current state we are not using, but see the mnemonics that is for the each characters, what is the name, like example NO means normally open, normally closed means NC, timer on TON or T1, and you can find all the options here. And if you go for connections, you can find here the PLC identification number, that is the PLC like computer, current computer name details. And also in the operator screens you can make, edit, create online default screen operating, etc. And for converters you can change from PLC to PL7, and also the concepts. If you have the concept application, you can directly import from, if you select these options, variable pipe, see here, and disable, like there is options here, na? Separate ladder logic, generate EF functions, etc. This all function for concept you can directly import as per that. And also further down you can see here you can export this complete project setting options. Once you export, you can utilize, see now I'm going to export this option called name called options. This is .xo file, and whenever I need to import for other project, similar project, I can directly import like this. Just double click and import and select this XO file. See, it is importing directly and it's imported. This means you can utilize the same project setting in any of the projects. Once you make at initial time one setup, you can use this file and it will make the project settings and project options similar for all the projects. No need to modify in each and every places. So we check that options and project setting. Now we are going to see the state RAM viewer. For that, go to PLC and click state RAM viewer. Here what we seen before in the CPU, the same for memory viewer or state RAM viewer. Here you can see the modules, variables and languages. Similarly what we seen before, the same. So this is one of the useful function to check the memory variables and everything. If you go further, you can find here the next useful tool is network inspector. Go to tools and you can find trending tools and network inspector. First we'll see the network inspector, because this network inspector you can see what are the networks available in the complete project. See here we can find CRP, CRA, these three networks, like main CRP for the main PLC, and for CRA it is for Rio modules. The next useful tool is customization. In the customized, you can find the tools which are available exactly in the menu, like in the menu downside. So you can add or remove the tools, like required tools in the menu here. See, now if I add debug watch point, see it's added automatically. So this will be useful for customized our toolbars in the menu. And if you go further in the tools, you can find here called diagnostic viewer. It's already available. If we click this one, it will become at the bottom of the software. And if you go further down, you can find trending tool. In this trending tool, you can find modules, trend diagrams, trend curves. Like if you have anything to make same like a SCADA, the trending tool you can find in the online. You can find the trending values and also for the statistics, and it will show you the name, address, commands, and also the trend values. and also you have option called FA diagram. You can add the you can see the these all features, FA diagram, statistics and trending diagram, everything you can see in the online. So this will be like additional added functions in the Unity Pro or control EcoStruxure Control Expert. Currently we did not configure anything for that trending tool. So this will be when you are in online, you can check this value. Now we are going to see another function. This is very important for us for DTM browser. This already we explained in many times in the other videos. If you need to add any of the DTM, like I see, if you click add, you can find all the listed modules in our system. If you need to add anything, you can add, or also you can see if you click the DTM browser hardware catalog, you can find, you have the list here, and you can add any vendor or groups or any other third-party devices here. And also the another important function is called library manage browser. See here you can find all the different types of functions and function blocks. You can find whenever you are using any applications inside the browser. See now, I just opened any one of the program, and if I right click, if you go to FFB browser, you can find FFB type. If I add AND, it can come here directly. This everything it is available in the library. See in the FFB type selections. So you can find all the library here. If you make see here HSB underscore ST, you can find the particular function block. Similarly, you need to browse. If you know the name exactly, like AND or set, reset, or any other functions timer, you can make directly. Otherwise, you can browse from library browser and drag and drop as well, or you can right click, select FFB and go to the browser, library browser, and you can find the same functionalities here. See, you can find here lot of functionalities, and even you can import some defined you are creating some new blocks. You can add directly in this type browser library browser itself. See here you have some one option I will show you. See here, if you go for FFP and if you browse, it will open the FFP type selections. See here you have option called application. Application means which you used already in your project. See these all functions it's already used. If you go libset, you can find here basic, communication, customs and everything. In the customs you can add anything as per your, like if you created any block, you can add in the customs. But if you go here in the base, it's having all the basic libraries, and you can see you have comparison, equal, less than, greater than, and also you can have date time. And if you go further down, you can find logics, and or XOR, not, rotate to left, right, shift, everything, mathematics. So you can see add, multiplication, move, negative, sign, subtract, and this type of functions you have here in mathematics. And if you go further down, we can find, see, communication, and you can find all the related to the controller. This is all related to the controller. And if you see further, this custom library, this one you can make. If you need to add any of your own function block, you can add in the custom family. If you go further, you can find diagnostics, and also you can find IO management libraries. See here you can find for analog scaling. See this one, you can use directly to your project itself. You don't need to create a new scaling blocks. At the time you can utilize this before that, if you add and check the help, you can find in the help as well. See here, you can find all the customized or already created scaling blocks here, analog IO scaling blocks here. So you can utilize directly in your project. See, you have all the functionalities here. And also similarly, you have motion function blocks, and also you have safety, and also absolute library. Like this is the old libraries which used for in previously these function blocks. And if you go for safety, you have lot of functions here in the safety as well. Because see, you have already, there is 4 types of software is there na? Unity Pro, small, large, medium, Excel, and safety. If you have, when you are using safety, you can find all that one in the safety. If you go further down, you can find Unity LL985. Whenever you are using the program for the Unity LL985, at the time you can utilize these functionalities. And if you click further for help on type, you can find the particular, when you select any of the function block, you can find the use of that same block. It can be it mentioned for each of them. See, now I click cos D for that, so it is showing the cos D. So this will be very useful for, if you need any useful for creating any of the function blocks in your project. And if you go further, we can find here, see here, lot of options in the menu. Now see, when we are going to the tool, you can find the other variables called, see, we have other things like here operator screen library. This operator screen library, you can create the own screen here directly in the operator screen. See, when you go to the operator screen, click new screen, it will be open same like a SCADA screen. And whenever you don't have any HMI or SCADA, you can utilize directly from this. See, in the right side, you can find the libraries for button, pumps, motors, valves, and everything. You can just add what tags, like what objects you need. You can directly add in your project, and you can link the IOs directly, and you can see same like animation for the any of the graphics. You can add, even you can make a control from here itself. Instead of going to the logic, you can make a control. You can this is, we can tell that SCADA or HMI for operator. Like if you don't have any PLC or SCADA system, sorry, HMI or SCADA system, you can utilize this operator screen. And here, see, you can add line, rectangle, like all the parameters. If you have any customized, like if you have any objects, you can add directly in this project, and you can implement for the project. See, here you have buttons. If I click the button, see, it will be add the button, and from this button you can link your tags as well, and you can make a control directly through this screen itself. You can tell that this is mini SCADA or mini HMI screens. And also you have a lot of other functionalities in the library of that operator screen library. And if you go further down, you have the documentation here. If you see here, you can add your title of the projects, designers, and also you have other parameters here. You can have attribute profiles, and also you have the, you can make your own like a printout setup for this project. And also you have other functionalities, animation tables, events, and events, it will be useful. This is under the program section. This everything we already explained in the previous videos. So if you watch that previous videos for the Unity Pro, part 1, part 2, part 3 and part 4, then if you come here, it will be more understand for everyone, because that one, it's having all the basics of complete projects. Because this one, just we are going to check only the existing project now, so you cannot understand all the concept here. So better watch that video and come and you can come to this advanced level, so you can understand the complete project. I hope you enjoy this video. If you like this video, kindly press the like button. If you have any comments or any questions, kindly add in the comment section. If the video contents are useful, kindly share to your friends and subscribe my channel. Thank you.